Hey everyone, let's take a look at this mini lecture on simplifying rational expressions. So the main thing you need to understand for simplifying rational expressions is that the process wants you to first factor, and when I say factor, I mean factor completely in the numerator and factor completely in the denominator. After you factor completely in the numerator and denominator, you can likely find things to cancel out. Let's get started on the first example. We have 2x plus 6 over 4x minus 12. The first step in factoring is looking for a GCF. I have a GCF of 2 in 2x and 6. They both have a 2 in common. That's the GCF. 2 goes into 2x, x times. 2 goes into 6, 3 times. I can't factor anything more inside of those parentheses. I can factor out a GCF in the denominator, a 4. 4 goes into 4x, x times. 4 goes into negative 12, negative 3 times. Now I can go ahead and simplify or reduce. 2 over 4. 2 over 4 reduces to 1/2. I can't cancel out x plus 3 and x minus 3 because they are not the same. So I go ahead and leave them alone, and that'll be my final expression. Note that I wrote the 1 in the numerator, but I don't have to because 1 times x plus 3 is just x plus 3. Now let's go on to the second example. X squared plus 9x plus 20 over 2x plus 8. I look for a GCF, but I don't have one. I see a trinomial here. The leading coefficient is a 1. It's invisible, right? So that tells me I can go ahead and use some simple method that I've learned, whether it's a product sum method or a box method, reverse FOIL, whatever you've learned, go ahead and use that method. So for myself, I make 2 sets of parentheses, put an x in each one. I'm saying to myself, what times what makes 20? And those same 2 numbers have to add up to 9. What times what makes 20? And those same 2 numbers have to add or subtract to make 9. So for me, it will be 5 and 4. 5 times 4 is 20, and 5 and 4 will make 9. Now it's just a matter of putting the correct signs in and making sure the signs work. Positive 5 and positive 4 make positive 9. Positive 5 times positive 4 make positive 20. So that works. In the denominator, I see a binomial again, and the first thing I always want to do is try to find a GCF. The GCF there is a 2. 2 goes into 2x, x times. 2 goes into 8, 4 times. I can't factor any more in the numerator or denominator. So next I'll just cancel out. The x plus 4's cancel out. Remember, when things cancel out, they actually leave 1's. X plus 5 times 1 is x plus 5. 2 times 1 is 2. So we're left with the expression of x plus 5 over 2. We go to my third example. 6x plus 24 over x squared plus 7x plus 12. The first step, always look for a GCF. So in the numerator, I'm thinking that the GCF is 6 because 6 goes into 6 and 24. 6 goes into 6x, x times. 6 goes into 24, positive 4 times. There's no GCF in the denominator, so I look at my denominator and I see an expression with 3 terms. It's a trinomial, so I'm just going to go ahead and factor the same way I factored that numerator in problem 2. So I'll put an x in each set of parentheses, and I'll say what times what makes 12, and the same 2 numbers have to add or subtract to make 7. Now if I picked 6 and 2, 6 times 2 surely make 12, but 6 and 2 do not add or subtract to make the 7. Now I try 2 different numbers, 4 and 3. 4 times 3 is 12, 4 and 3 do add to make 7. And now it's a matter of putting the correct signs in. After that, I see that I can't factor anymore. I go ahead and cancel out. Remember, when things cancel, they leave 1's. So we get 6 over x plus 3. And that's my final expression. Alright, let's move on to the fourth example. The The fourth example says 3x plus 18 over x squared plus 6x. It looks to me like a matter of finding the GCF again. That's what we always would like to do first and foremost. The GCF of 3x plus 18 is 3. 3 goes into 3x, x times. 3 goes into 18, 6 times. In the denominator, it looks a little bit different, but we're still looking for a GCF. They have no number in common except for the number 1, but we never use 1 as a GCF. They both have an x in common, so x is our GCF. X goes into x squared, x times, right? Because x times x makes x squared. When you multiply, you add the exponents, so we get the x squared back. Alright, now x goes into 6x 6 times. There's no more factoring that can be done, so the x plus 6's cancel out, and we're left with 3 over x as the expression. Alright, in the next example, we have 3x minus 12 over 3x squared minus 12x. We always want to look for a GCF first and foremost. The GCF of 3x and 12 is 3. They both have a 3 in common. Not the x, right? Because they don't have the x in common. Only one term has an x. So 3 goes into 3x, x times. 3 goes into negative 12, negative 4 times. However, in this bottom one, they have a 3 in common. 3 and 12 have a 3, and x squared and x have an x in common. So 3x is the GCF for that denominator because they have a 3 in common and an x. 3x goes into 3x squared, x times. 3x goes into negative 12x, negative 4 times. And remember, when pulling out the x as a GCF, we have x to the second in the one term and x to the first in the other. We always use the lowest exponent. Alright, now I look at it and I say things can cancel out, like the x minus 4's. Also, these 3's can cancel out. So we're left with, and the numerator, 1 times 1 is 1. X times 1 in the denominator is x. So 1 over x. And now in this final example, we have x squared minus 5x plus 6 over x squared plus 2x minus 15. So what's the first step? Always look for a GCF. There seems to be none because we have a 1, a negative 5, and a positive 6. The only number they have in common would be a 1, which we don't use as a GCF. So I'll go ahead and factor. I'll say what times what makes 6, and the same two numbers have to make 5. That would probably be 3 and 2. 3 times 2 makes 6, and 3 and 2 when we add or subtract make 5. Now we have to get the signs correct. It looks to me it has to be a negative 3 and a negative 2 to add up to make a negative 5. And then I test it again and say a negative 3 times a negative 2 makes positive 6. Correct. Alright, in the denominator there is no GCF, so I'm going to factor that. And I'll say what times what makes 15, and the same two numbers have to add or subtract to make 2. Well, I know 5 times 3 is 15, and possibly 5 and 3 can add or subtract to make 2. So it's a matter of getting my signs correct. It should be a positive 5 and a negative 3, which will get me a positive 2. And a positive 5 times negative 3 make a negative 15. So the signs work. It's a matter of not just getting the numbers correct, but also the signs as well. So now we go ahead and cancel out the x minus 3's. And now we have 1 times x minus 2 is x minus 2. X plus 5 times 1 is x plus 5. And that's our final expression.